Okay. Hi guys. We stay here at the boat from Open Boat Project, and on my side is Matti. Nicht Matti, is Teppo. Teppo from Finland, from Signal K, and we discuss a little bit over Signal K.
Thank you.
I think Teppo give a short overview what is Signal K and what can do with Signal K, and after them I ask him a little bit questions and we discuss over the future.
Okay.
Okay. Teppo.
Hi, everybody. Maybe there's somebody actually listening to this. So, my name is Teppo, and I've been with the Signal K software project since the very beginning. And it started something like this. I bought a sailboat and I wrote some software for my own boat's data, being a nerd. And the next season I bought new devices. And then I realized like the previous year's software did not work. But it was so tightly coupled to NMEA 0183. And I had bought some NMEA 2000 stuff and they just didn't work together. So I needed to rewrite everything. And then I was thinking like, this is really stupid. Am I the only one in this universe who is thinking like, having this problem and thinking like, this is really stupid? And that led to this GitHub issue where we started discussing sort of having a universal format for interchanging marine data. And one thing led to another, and today we have Signal K software, data model, and protocol. So what is Signal K? It's easy to say like it's some software, and it's a data hub for your boat. So it's a hub that brings together all the data that is produced and available on a boat. But it's also some user-facing software. You can build dashboards or chart plotters, and you can do telemetry, so handle all your data, put it in a database, draw some nice graphs from that. But there's also the data model part, which is basically it's just keys and values. What do you call this value? So that's the key, and then you have the values coming in, like what would be a good example? For example, your depth sounder saying like, okay, now it's 3.6 meters, now it's 3.7 meters, and that's called environment depth below keel, for example. And then it's a protocol. All the earlier protocols were not very well suited for today's computers and today's applications. So we picked a protocol for how a client here is like a user-facing application, like a KIP dashboard that you see in the top right, how that gets the data and what each piece of data is called. And you can stream updates through a WebSocket connection with authentication and access control, and using JSON as the format. So maybe that will give you a sort of like a quick idea of what Signal K is. But what can you do with Signal K? It's kind of a Swiss Army knife for marine data, since it's a model that can present all the data that you have available. So if you have the data all in this one data model, then you can convert between the different formats. And you can even handle different kinds of data that the official standards have no way to represent, so it's extendable. My favorite example is that if you have a jacuzzi on your boat, you can put the jacuzzi temperature in the single K data model, and then your system can go beep when it's available for enjoying your jacuzzi. And then there's the kind of a pretty obvious glass bridge chart plotter application. You can customize dashboards and chart displays and overlay the data on that. Since all the data is in the same data model, you can do telemetry. You can pick your choice of database, put the data in there, and use different open source or commercial solutions for graphing your data, or maybe setting alerts and analyzing sort of like how was your electrical system doing during last month's cruise. Remote monitoring is something that you can do with this. Naturally, it requires that you have internet connection from your boat. But after that, all the data that you have on board is available remotely also. You can do automation, you can control onboard devices like lights and that kind of stuff. And you can add rules to trigger actions. People also like, when it gets dark, turn on the Danko light, that type of thing. And then there's like an open sensor integration. You can get off-the-shelf wireless sensors like Rovi tags, or you can build your own sensors and incorporate all of that data in your single K system. And one pretty big application area is power and energy management. You can connect Victron systems or other battery and electricity systems to your single K system. And the nice part there is that you can, as I said earlier, put all your data in a database and have it available afterwards to troubleshoot and figure out how your system is doing. And then there's cloud integration. You have an onboard logbook and you can sync that. You can sync your anchorages, your anchorage visits, and all of your data to the cloud. A bit of a background noise, but that happens. So the question is, what would you want to do with your boat data and the electronics? Single K can probably help. Here's an AI-generated infographic of some sort. This you can take home with you, sort of like it's a Swiss Army knife for dealing with your all marine data protocols and needs. So what's new right now? We recently introduced a WebAssembly plugin support. Earlier we were supporting only JavaScript for writing extensions, but now it's perfectly possible to use Rust or AssemblyScript or other languages for creating plugins. Then we nowadays have a single sign-on support with OpenID Connect support, and we have done, like every decent software, we have done security fixes. So if you're running an internet-facing single K server, please update to minimum 219 or actually 220. We have History API that standardizes the way single K data is made available from a history database. We have nowadays supports for something called Parquet, which is the modern way to store your data. KIP is, I don't know if you can see it in the picture. No, you can't. KIP is, no, I'm not going to go back because that's not working very well. KIP is the most used single K dashboard application. It's improving all the time. We did some improvements on the WebSocket performance and stability. And nowadays there's a weather API that you can use to include weather forecasts in your single K system. and we have an autopilot API that allows control of autopilot, sort of like engage, disengage, 10 degrees to starboard, that kind of thing. And there's when you write the user interface, you don't really need to care which autopilot is being used, because you just talk to the single K API, and there's a background adapters that talk to the different autopilots. That was what we've launched lately. What's in the pipeline? Container-based installs. We have people working on a universal installer and something called, how do you spell it? Halos, something like that. HAT Labs operating system, which is going to be a container-based marine operating system. So these should make update or keeping single K system up to date much easier. And then we're introducing radar support, which is going to make radar control and radar data overlays available in your single K system. And last but not least, I'd like to mention that our development pace is picking up. We have more contributors, and we get a certain tailwind from AI. There's been a sort of like a definite influx of more contributions aided by AI. Nowadays, we're more into what we want to build instead of the nitty-gritty details of how to code it. And people often ask, like why the name Single K? What's this stuff?
Yes, okay.
Single K is the old signal flag, whose meaning is I wish to communicate with you, and that's the idea with Single K. We want to be an open system that makes data interchange easy, and systems can talk to each other. I think I've exhausted my presentation.
Yes.
How was it?
Teppo, thank you very much for your explanation. It was very interesting for me and I think for all other people, and also that you give an overview for the future. I see it that you want to integrate radar systems, and it is also very interesting for the own projects. We have several display types, and we want to integrate also in other systems. No? And it is interesting when you develop this system in this direction that we can integrate this information in other systems. So.
Yeah, that's kind of the idea that since all the modern yacht radars are sort of, they're talking Ethernet.
Yeah. But
the protocols are all closed.
Yeah.
And the idea with the rewrite of the radar server that Kees Verruit has led is that in addition to making it sort of open source, there's going to be an open protocol.
Yeah.
So same thing like with the autopilots.
Yeah.
A UI user can just make a panel the way they want it to look, and there can be a button like increase range, decrease range, and they can talk to the open radar API, and then that talks to the actual radar and makes it change the range.
Okay, when I understand correct, then is it closed source for the protocol, transmission protocol, and you or your peoples re-engineered this protocol to an open protocol?
Yeah.
In which people working? Also, what's the name? Where's the developer for the technique?
You can come to Signal K Discord server where there's a dedicated radar channel where people can come in for more information.
Yes.
But the open source software project that is actually developing the radars is called Mayara.
Yeah.
Mayara, Marine Yacht Radar.
Yeah. Okay. I understand.
So Signal K is developing the APIs,
Yes. Okay.
and the actual radar server is coming from Mayara.
Okay.
Well, that's same people but different.
And which radar devices you support with your software? What is actually possible?
I looked it up a moment ago, but I already forgot.
Okay. Yeah, that's very interesting. Any people ask me, what can I do to show radar systems enough, and which radar systems can I use?
That's all the Navicos are. The modern Navicos are supported, and then there's incoming support for Furuno.
Yeah.
And I think Raymarine Quantum 2, I think.
Yeah.
But anyway, that's kind of like a moving target.
Yeah. Okay.
But the idea is that anything that can run a browser can show the radar picture.
Okay, and the problem is to adjust the normal navigation with radar information. What is the technical background to match both maps?
Well, since the radar is kind of like we know where the boat is and which way it's heading, we can do the overlay on the marine chart. This is actually this image that I'm showing is from a Signal K chart plotter application showing the marine data.
Yeah. Okay, but you need a heating sensor, magnetic heating sensor or GPS heating sensor, or
GPS and
GPS is enough.
and no, you need to also the heading.
Ah, yeah, okay, good, I understand. Yeah, very nice. Teppo. Okay, thanks for watching.